Hey y'all, welcome back to Kelvin's Classroom. Thanks for coming. Today we're going to be talking about digestion. I don't know about you guys, but for me, I'm always thinking about food. Either I'm thinking about food that I want to eat, food that I am eating, food that I just got done eating. I'm always thinking about food, and it's pretty important for our body. It's how we get energy, right? We need energy to be able to make it through the day, and the way that we do that is by eating food. So when we think about food, no matter whatever food it is, if you're thinking about pizza, you're thinking about fish and chips, you're thinking about a salad or even an apple, all right, now I'm hungry, so I'm gonna have to get something. All right, this will help. Plus we can use it as we're talking about this. So I'm thinking about food. All this is stored energy, right? Now I enjoy it because the taste, the emotional feels, all of those things, but all it really is stored energy. And all digestion is taking that stored energy and changing it to something that's usable for your body, all right? Now, what we're gonna talk about today, we're gonna talk about the digestive system organs. We're gonna look at the hollow organs as well as the accessory organs, talk about which ones are which and where they're at and what they do. Now, if, as I said those things, you were wondering, what's a hollow organ? What's an accessory organ? That's okay, I'll explain that as we go. Then we're going to talk about the function of the digestive system. What's happening throughout all of the different parts of the digestive system and why is it happening? Finally, we're going to think about what is digestion. Just generically, what is digestion and why does it matter? Well, if I'm thinking about this, the first thing that we should probably look in is what is digestion. So let's go ahead and dive in. All right, so digestion, like I said, it's taking this food, chemical energy that is just stored, turning it into something usable by my body. Because if I were to take this apple, I can't put it anywhere and just plug it in for it to work. I have to take it inside my body, deliver it all around the body in the form of usable energy. Now, when we break this down, most of the time we're going to think about breaking down food into its individual, tiniest little pieces. We call them monomers, but they're smallest little pieces they can do. And how do we do that in digestion? Well, digestion is made up of two different processes. One is called physical digestion. Now, I want you to think for a second, what might be parts of digestion that are physical or mechanical digestion? Why you guys do that? I'm going to take a second, and I said I was hungry. I'm going to start to enjoy that. Now, I'm hoping you guys have thought chewing. That's probably physical digestion, right? You're absolutely right. That's the first type of digestion that happens in the body, is chewing, which is our first type of physical digestion. Now, chemical digestion is different to physical digestion because I'm not causing a physical force to break up into smaller pieces. Chemical digestion is when I use enzymes. Now, don't worry about if you're saying, what's an enzyme right now? We'll have a lesson where we talk about it. In fact, you can go ahead, check out that lesson, come back here if you want to, or wait till the end and go check it out. Now, enzymes are chemicals in the body that help break down the food as well. So instead of me chewing it, instead of that, my body breaks it down. Now, where does chemical digestion start? It starts in the mouth as well. And when we start to talk about enzymes, we're going to look at what enzymes are working in there. But as soon as the food gets into the mouth and I'm chewing it up, I also have saliva, right? Now, a good way to kind of trigger this is, as you're sitting here, what I want you to think about a food that you like. So if you like fish is a really good one. If you don't, think about steak, or maybe you're a vegetarian and you just want to think about any of your favorite roasted vegetables that you really like to eat. Okay, picture it. You gotta imagine it sitting there on a plate. Now imagine you're sitting there at the table and you pick up a piece of lemon and you squeeze that lemon across the top of that fruit. As you do that, your body probably started to create saliva. Now, we do this because citrus in our brains, when we see, smell, or think about citrus, we start salivating because we get excited to eat. It's one of those things that encourages us to eat. So as you were visualizing that, you probably started to salivate. This saliva, which looks like it's just water, has enzyme in it, and that's where we start chemically breaking down food when it enters the body. Now, after this, There are other places throughout the body where either physical or chemical digestion happens, and we'll talk about that as we go through. But all that we're thinking about is the different places where either we have something that's physically breaking apart the food or chemically breaking apart the food to make it as small as we can, because the apple can't get into my blood. It can't pass through the membranes inside my body to get to the blood. It has to be really, really small to be able to do this. So let's go ahead and dive in and take a journey through the digestive system, starting at the mouth, working our way all the way through, thinking about what the different organs are and what's happening at these organs. So first place digestion happens, mouth. We think about things like the teeth, which are where we're starting to physical digestion. We can think about the tongue, which helps us to move the food around, to taste the food. It helps us do a little bit of breaking down, but not a whole lot. We think about the saliva, which comes from our salivary glands made in the mouth that starts to break things down. All of this is happening inside the mouth. Now, hopefully, when you're eating, you chew your food plenty, you don't choke on it, but even if we chew our food really, really well and then swallow it, the food doesn't spend too long in the mouth, right? It quickly goes into the esophagus, which is one of the two parts of our throat. Now, we have right here, if we can feel, it kind of feels bumpy. That's not the esophagus. We're not thinking about the esophagus there because that's the trachea. That's where when we're breathing. We think about the esophagus. It's kind of like a really flat, hollow tube. And as we swallow, it allows the food to travel down it. Now, as that food's traveling down it, we see a bunch of contractions. This is called peristalsis. This is taking that food that you swallowed and just pushing it all the way down so that way it can get into our stomach. This is why sometimes when you're eating and you take a bite of something and you swallow and you're like, oh, it really hurts going down, it gets a little bit stuck in that esophagus, and the esophagus just uses those muscles to push it all the way down into your stomach. Now, once food enters the stomach, we typically wouldn't think about it as being an apple eating there. We think about it as kind of a chewed up piece of food that can make its way into there. We start referring to the food as a bolus. Now, all this is talking about is a chunk of food that's traveling through the body. So as the bolus enters the stomach, a few things start to happen. Now, when we think about the stomach, we don't think about it as being like the rest of our body. It's a very acidic environment. Now, there are reasons for this. As we talk about when we think about response to infection in the body and how our body keeps us healthy and safe, this is one of the ways we do it. By having that acidic environment, we kill any microorganisms that make their way in there. So if you're thinking about that dinner you ate last night and you weren't really sure if the chicken was fully cooked or not, one of the ways your body protects you is that acid tries to kill as many of the bacteria as it can to help keep you safe. So the stomach, which is kind of stretchy, and you can almost imagine it going out and in, kind of like an accordion, right? When the bolus gets in there and we have all that acidic juices in there, it stretches and contracts and stretches and contracts to move that around to break up all that food. That's a little bit more physical digestion as it's physically moving it around, causing it to break down into smaller and smaller pieces. Right? We can kind of imagine if we have a milk jug and we have some milk in there, we hold it on its side and we shake it side to side. That's kind of what's happening, but instead of moving it, it's just because we're opening it and closing it. So that's some physical digestion that's happening in there. In addition to that, we have some chemical digestion happening. We have enzymes that get released in the stomach that continue to break down the food. The enzyme that we're seeing inside the stomach is protease, which we'll talk about more later, but it starts to break down proteins. In addition to that, we have hydrochloric acid we talked about, which kills the microorganisms. It's also helping with digestion a little bit, breaking things down. We're churning, that's that contracting and relaxing of the stomach muscle. We're churning that food into a chyme where it kind of mixes it all up, breaks it all down a lot, and it's really, really acidic. Now, the next step on there is after we've been in there and we've mixed up and we've broken down, we start to leave the stomach and we go into the small intestine. If we think about the stomach being a really acidic environment, the rest of our body isn't an acidic environment. So it would be really bad if we took stomach acid and said, okay, you can leave and let it travel through the rest of the body. We'd start to see a lot of damage there. We don't want that. So the first thing that has to happen is we have to neutralize that. Now, if you're like, I skipped chemistry today, I don't remember what neutralize means. All it means is we're gonna take that acidic material and we're gonna make it less acidic. We're going to move it more towards a neutral state that doesn't damage the rest of the body, because inside the stomach, we like to be at about a pH of 2. Inside the rest of the body, we want to be about 6.8, 7, somewhere in that neutral range. So the first thing we do is we're going to neutralize it. Now we do this by putting bile on it. Now, we'll talk in a little bit about all of the accessory organs and all of the things that they do, but for now, we can just think of bile as coming from the gallbladder, which is where it's stored, and being secreted. It's kind of like just this chemical that has two main jobs. The two things that it's going to do is, one is it's going to neutralize the acidic bolus that's coming out of there, right? It just came from the stomach. It's really acidic. We don't want it to be acidic traveling through the rest of the body, so we need to neutralize it, and bile does that. So it's an alkaline chemical. The second thing it does is when we're eating food, we think about them in three different groups usually, either carbohydrates, proteins, or lipids, or fats. Now, fats, as they get broken down inside the stomach, they're usually big blobs, right? So for this, you can just imagine, think about taking some oil and dumping it into a bottle of water, and you can see those little balls that are in there, right? That's kind of what fat does. It makes little balls, sticks together in big groups. Well, that's not going to be very useful. We want these in really small ones so we can break them down better. So bile comes on there, breaks it down into smaller pieces, right? So that way each of those small pieces have more access to being broken down by the enzymes that are going to come along and break them down. All right, so we have this bile that got secreted. It came from the gallbladder, which is where it was stored, not where it was made, just where it was stored. Anyway, our bolus is going to keep traveling. Now it's in the small intestine. So in the small intestine, it's going to have a really long journey. So we call it the small intestine because it's really, really narrow, but it's really, really, really long, right? That's one of the really important things about it, is how long it is. So it's really long, allows the food to be able to travel all the way through it, constantly in contact with the wall. So as it's being broken down more and more and more, once they're broken down into those small monomers that we talked about earlier, the body can absorb it and take it into the bloodstream. So to do this, we need it to be very narrow. You can kind of think about this like a really narrow maze that you're walking through, where as you're walking through, you're constantly touching the sides of it, right? And as the food is slowly being broken down, eventually it can just be pulled in and absorbed into that. So if you're walking through this narrow maze, just imagine you're walking through and all of a sudden something grabs you and pulls you in. That's kind of what we're seeing happen with that food. As it's small enough, it can just be taken into the walls. So inside the small intestines, in addition to it being really long and really narrow, we see enzymes being secreted. Now, the enzymes that are being secreted are breaking down any of the type of food that we have in our body. Right, so it gets secreted on it, chemically breaking it down, getting it to where it's small enough to absorb it, getting all of the nutrients we can out of that food. After it takes this really long journey where we're absorbing all of the food that we can, all of those nutrients, the main goal of digestion is happening now. We're taking that food into our body to be able to be used. We hit the large intestine. Now, as we're traveling through the small intestine, we want it to be able to move fairly easily. We don't want it to get stuck. It's got a really long journey. We want it to be able to move easily along there. When we get to the large intestine, it's a much wider intestine. It's a lot more space in there, right? So it doesn't have to worry about bumping into the sides as much. We've already pulled all the nutrients out of it. So now what we need to do is we're going to remove water. We wanted a lot of water in there as we traveled through the small intestine to help it keep moving along. We don't want to lose water. We need water to survive. So the body pulls all of that water back out of that substance that's traveling through the large intestine. It travels up, over, and back down, gets to where it's about to be done. All of the nutrients have been pulled, all of the water has been pulled, anything extra that we need in there. All that's left is waste. We no longer want what's in there. There's no use for it. It then enters the rectum, which is our storing point for where we store our feces before it's about to leave the body. The anus is that exit gate that doesn't let it out until our body's ready. Once it gets into the rectum, your body realizes, okay, I have something I need to get rid of, and then we release it through the anus, and that's the end of digestion. That's starting with our food, taking all of the good things we can get from it, and getting rid of it. All of the organs we just talked about where the food's traveling through is a hollow organ. I'm hoping you can figure out that that's because it's hollow on the inside. The food travels inside it. The inside of it is hollow. We have a few other organs that help with digestion though. These are called accessory organs. So kind of like when you're getting ready to go outside, you put on all your clothes, put them on, and you're like, all right, now I'm gonna put on my accessories. I'm gonna wear a tie, I'm gonna grab a purse, I'm gonna put on my watch, whatever it is. The accessory is kind of an add-on, but really important still. Now the food never travels through any of these. They're attached to it and on the side. The main ones that we have would be the liver, the gallbladder, and the pancreas. Now, we already talked about the gallbladder, so let's start by talking about the liver, which is where the gallbladder is attached to. Now, the liver has a couple main functions. One thing that it does is it's really good at storing glycogen for the body. Another thing that it does is really good at filtering things out in the body. So it filters out things like toxins from your body. But in relation to digestion, the big role that it has is its job is to make bile. It makes bile, gives it onto the gallbladder to store it, and then release it as it's needed. So really important thing for it. It's constantly making bile, filling it up to the gallbladder, so that way when the gallbladder needs to release it, because food's coming out of the stomach, it has some to release. The gallbladder, its only job is to store and release the bile, right? So it's just kind of a storage tank. And then our last one is the pancreas. Now this is the one that does most of the work when it comes to enzymes, because the pancreas makes all of the enzymes that our body would need for digestion, right? So when the food is entering the small intestines, and I said all of the enzymes are mixed in with it, they're all made in the pancreas. Now when we're looking at it, I kind of think the pancreas kind of looks like a long, weird little leaf of seaweed or something like that. That's how I remember it. I remember the liver because I feel like it kind of looks like a racing hat for a bicycle racer, right? Kind of looks like that pretty large organ in there. And the gallbladder is just that tiny little one attached to the bottom of it. Now, these are all the main organs. These are all the main functions of the organs, and this is what digestion is. We'll talk more about the enzymes and how they're doing their job. But the last thing you really want to think about is thinking about the organs and their functions. How is it that they're designed or made in a way that makes them really good at their job, right? So for example, for some of these things we might be thinking about is teeth. How are our different teeth designed for their job? Whether it's my teeth that are made for grinding or for chewing or for cutting, right? How is their shape, their structure adapted to their job? How about things like the stomach? What makes the stomach good at its job? Well, it's an acidic environment. So it needs to have juices on the inside to protect it from getting damaged, right? It needs to be stretchy to be able to expand and contract. Small intestine needs to be thin and long to be able to allow things to move through it, right? Those are really important functions that fit the structure of the digestive system organs. Now, all of these work together to take that stored energy inside the food, break it down, bring it into the body, and allow our body to use it. Next time, we're going to go ahead and take a look at the enzymes because we really quickly jumped over them and just mentioned them. We need to spend some time actually diving in. What are enzymes? What do they do? How do they do what they are? What are the different ones and where are they made? These are really important things for us to understand. So thanks for coming by today, everyone. I hope you learned something. Hope you enjoyed it. Please like, subscribe, comment down below. If you found it useful, share it. Maybe someone else will find it useful. If there's something that you're interested in to find out that I didn't cover, you have a question, again, throw it down in the comments. I'll take a look at them and I'll get back to you as soon as I can. Thanks for coming by, guys, and I'll see you next time.